Okay, I'd like to start by showing off some of the creative things, some of the most creative things I've seen for the last assignment. So I'm just going to play through those really quick. Here's the first, and you can see that the explosions explode into rings. So that's pretty cool. That took a little effort. Let's go to the next one. This is, a lot of people did various things with gravity, but this is the first one that I've seen that had gravity going towards a fixed point rather than just pulling off in a downward or upward or angled direction. So that the ability to orbit something is really very cool. Let's see, what else? So here the particles, they don't fly straight, they fly in a squiggle pattern. That's pretty cool. That took some effort, or at least some thought. It was actually a surprisingly small change to the program. This one, this is really awesome. You have to kind of wait for it. But, so the particles fall through the bottom, and they split and then split again. The other neat thing about this application is the student figured out how to resize the application to fit the computer screen. So I've got a couple of different computers. They have different screen resolutions. When I run this app, it maxes itself out. It runs essentially full screen, no matter what computer it's on, that's a pretty cool thing that I did not show you guys how to do. He just figured it out on his own. It's actually something that I've never done before. So that's very cool. And the last one that I want to show is shoots multiple fireworks at one time. So that was pretty cool. Weird kind of thing goes off in the wrong direction. That's a little bit weird. I don't know if that was intentional or not, but it is what it is. I like to see the creative things, the things that are different, the things that I hadn't expected. I really especially liked this one. This is just really amazing. It just blew me away. So please keep that coming. All right, so the next thing that I would like to do is I would like to just add a little visualization to our little audio program. So if I've got a JFrame and I want to draw in some panel on it, I'm going to create a new class that extends JPanel. So I'm going to say File, New, Class, and I'll call this AudioViz. For the visualization of the audio, it's going to extend JPanel. Got to import JPanel. And inside of AudioViz, I guess I got to add the default serial version ID and delete this comment that it's automatically generated for me. If this is going to be something that just paints itself in a screen, it's going to need some sort of a paint method, and because it's a component of something else, it'll be a paint component method. So public void paint component graphics G, and we've done that before. We did a paint component when we did the maze application. It's kind of a similar thing, and if we're going to use graphics, we got to import graphics. So next thing that I would like to do is I would like to have an array of shorts, and I'm going to call it samples. So we're going to display some audio stuff, and the audio comes in as a bunch of samples, and each sample is essentially a number that tells the speaker cone where to be. Okay? So in our Can You Hear Me Now application, what we did is we just, in the run method, we read a bunch of stuff into a buffer. from the microphone, and we immediately just wrote it out to the speaker from the same buffer. So this is the buffer, and it was just an array of bytes. So a byte is just 8 bits, and each bit can be 1 or 0. A short is like an int, except that an int takes 4 bytes, and a short, well, it's shorter than an int. It only takes 2 bytes. So a byte is 8 bits. So if we think of a short, we've got 1, 2, 3, 4, 5, 6, 7, 8 bits. Each bit can be a 1 or a 0, all grouped together into 1 byte. So we've got 1 byte and then another one. Now, when I say this represents a number, it's all ones and zeros, and it's a number a lot like the base 10 numbers that you're familiar with. So normally, if I write 20, let's say 25. Okay, if I write the number 25, you have this sort of intuitive feeling for what that is, because you've been working in base 10 all along. There's 10 different digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But computers, they don't see things as having 10 different symbols. Actually, I'm going to say 10 symbols per digit. It's not. They only have 2 symbols. It's just a switch. It's either on or off, open or closed. Well, we think of them in programming as if it was 1 or 0 for each digit. And so when you've used up all the symbols for one digit, you roll over into the next one. So once you get to 9, you add 1, you go into the next digit with a 10. And then when this first digit, the ones digit, goes up past 9 a second time, you carry another one over to the next digit, and it's a 2. And when the second digit gets up to 9 and you want to add one more, it carries over to a third digit. So we like to think of this first spot as the ones place, because each symbol represents one more than the next, okay? And then we like to refer to the next spot as the tens place, because each time that rolls up to something a little bit bigger, we've got 10 more of them. It's basically, because this represented 9 and we've added one more, now it's a 1 and a 0, well, now we've got 10. So we think of it as a tens place. Now, in binary, what your computer does is you've got a ones place and then a twos place. Okay? So it's a ones place. And I'm just going to write a number. This is the ones place. And the next one is the twos place. And the next one is the fours place. And the next one is the eighths place. So this symbol represents 1. When we carry it over, this symbol would represent 2. When this gets carried over, it's 2 plus 1, which is 3. When you add one more, it becomes 4. So you've got a 1, 0, 0 is 4. And then when you carry over the 4, you've got a 4, a 2, and a 1. That's 7. You add one more, you carry over, and then it's 8. Just like if we had a 9 and a 9, that's 99. We carry one over, it becomes 100, so we consider that the 100s place. And this, the next place, so this is doubling each time, right? 1, 2, 4, 8, and then there's 16, 32, 64. Now, in the app that we wrote, there was a little thing when we initialized this where we said, is BigEndian false? So we're not using BigEndian. What is BigEndian? Well, essentially each memory location, each one of these is a memory location, okay? And we're wanting to know, is the biggest digit on the got an address that's higher? Okay, so I'm going to just say that addresses are going to increase to the left. Now we normally think of the thing on the left as having greater significance, all right? We call it the most significant digit. If it's got like the tens place is more significant than the ones place. And so this last digit would be thought of as the most significant digit. But sometimes computers store things in a reverse order, and most of the time we don't even think about it. But every once in a while, we have to pay attention to which digit is considered the most significant digit and which digit is considered the least significant digit, because it changes the interpretation of the number. Why does it matter? It matters because we're going to be converting these numbers from arrays of bytes to integers, to essentially an array of shorts, because we would like to treat it like a number rather than just treat it as a bunch of ones and zeros. So let's write a little bit of code. I'm going to stop this video and start another one so that you can watch it in chunks and be able to more conveniently stop and start.